For the sphere x²+y²+z² equal to a square in the positive octant with this density rho xyz equal to mu into xyz, we need to find the coordinates of the center of gravity where this mu is constant, right? So the sphere is in the positive octant. This green colored portion is having the sphere in the positive octant. And when we consider the spherical polar coordinates, then the limits of r is from 0 to a. The limits of theta is from 0 to pi by 2. Please remember this always. And the limits of phi is from 0 to pi by 2. Right? So let's take V to be the volume of the sphere in the positive octant. And let G to be the center of gravity of the solid in the form of the sphere. So it is the center of gravity, that is Cg, of the solid in the form of the sphere. Then this x bar is, the value for this x bar is the triple integral over the volume V x into rho dx dy dz divided by the triple integral over the volume V rho dx dy dz. This is the formula for x bar. Similarly for y bar and z bar. So let's find this first. So this is equal to the volume integral. Okay, what is rho? It is given to us, it is mu into x y z, then dx dy dz divided by the volume integral of, again rho is mu x y z dx dy dz, where mu is constant. And now we are going to change x, y, z to the spherical polar coordinates. So for that we take x to be r sine of theta cos phi, y is r sine of theta sine phi, and z is r cos of theta. And then dx dy dz, this will be r square sine of theta dr d theta d phi. Let's put all these values. So x bar is equal to the volume integral of x. X is r sine of theta cos phi, then mu into x into y into z. So again x is r sine of theta cos phi into this y, that is r sine of theta sine phi, into z, that is r cos of theta. And then for dx dy dz we write r square sine of theta dr d theta d phi. All these are multiplied together divided by the volume integral of rho dx dy dz, again mu into x y z. Okay, so here I am having r square, and from here we get r cube, and here I am having r. So we have r the power 6. Then is sine theta, then sine theta, sine theta, sine cube theta, and here sine theta again, that is sine the power 4 theta. Then we have cos theta. Then is the sine phi. And cos phi, that's it. Cos square phi. And also there is mu. So this is dr d theta d phi. Similarly in the denominator also we get the volume integral of mu into, let's multiply. So this is r square r. So this is r cube into r square r the power 5. Then is sine theta, and here also sine theta, sine cube theta. Then is cos theta also there, and sine phi, and at last cos phi, and that's okay. So the remaining is cos phi. dr, d theta, d phi. We also have to put the limits now for r, theta and phi. So limits for r is from 0 to a. The radius of the sphere is a. Then theta is from 0 to pi by 2. And also phi is from 0 to pi by 2. I hope it's very clear. Let's integrate first with respect to r. If I take this mu outside of these two integrals, these two will be cancelled, right? Now integrating the integrand with respect to r, we get r the power 7 divided by 7. Writing the remaining things, d theta, d phi. The limits of r is from 0 to a, divided by the double integral. Integrating with respect to r, we get r power 6 divided by 6 from 0 to a limit, and writing the rest of the things. So in the numerator, when we put the upper limit and then the lower limit, we get a the power 7 divided by 7. And in the denominator, we get a the power 6 divided by 6. So this will be cancelled on and we get a in the numerator. So this is 6a divided by 7. So let's write this outside. 6a divided by 7. And now integrating with respect to theta. Writing this as it is. Sine phi cos square phi d phi. When integrating with respect to theta, and because the limits are from 0 to pi by 2, we can use the reduction formula on this. So for the numerator, we always subtract the odd numbers from the powers, right? So 4 minus 1, 3, then 4 minus 3, 1. We have to subtract until we get 1, right? For cos theta it is 1 only, divided by, just add the powers, 4 plus 1, 5. That is 5, and now we have to subtract the even numbers. 5 minus 2, 3. Then 5 minus 4, 1. Similarly, the denominator also, if we integrate with respect to theta, let me write this as it is. Here also we are having the limits to be 0 to pi by 2 for theta. So now using the reduction formula on this. For the numerator, we don't have to write the power. We just need to subtract the odd numbers from the odd power. 3 minus 1, 2, and 3 minus 3, that is 0. You have to stop here. Then divided by, sum up the powers of both these two. So 3 plus 1, that is 4, into, now subtracting even number from this number. So 4 minus 2, 2, and 4 minus 4, 0, that's okay. Stop here. So cancelling this 3 with this 3, this 2 with this 2, and we get 1 by 5 divided by 1 by 4, that is 4 by 5. So this is 6a divided by 7 into 4 by 5. And now the remaining integration with respect to phi of this, sine phi cos square phi d phi divided by the integration of sine phi cos phi d phi. So 6 into 4, that is 24, divided by 7 into 5 is 35 into a. Integrating with respect to phi. Okay, now again using the reduction formula. We have 2 in the power. So subtracting the odd numbers, 2 minus 1, that is 1. So we get 1. Divided by, for the denominator, add these two powers, we get 3, and now subtracting the even numbers. So 3 minus 2, that is 1. That's it. Stop here. Divided by, for this integration, we have 1 in the numerator, divided by, sum up the powers, this is 2, and then subtracting the even number. So there is no even number, 2 minus 2 is 0, so we don't have to subtract anything over here. So just only 2 is there. and this is 1 by 3 divided by 1 by 2, that is 2 by 3. So this is 2 divided by 3. So that gives, so 3 is cancelled out with this, here we get 8. So this is 16a divided by 35, the value for x bar. And by symmetry we can get the value of y bar to be 16a divided by 35, and also z bar is 16a divided by 35. This is by symmetry. So the center of gravity, that is x bar, y bar, z bar, I'm putting the values over here. So we have 16a divided by 35, 16a divided by 35, and z bar is also 16a divided by 35 is the required center of gravity of the solid in the form of the sphere in the positive octant. Alright, thank you.